channel, and I want to welcome you and let you know what we have in store and talk about a few things. As an engineer myself, one of the things that I've noticed is a really big gap when it comes to 3D printers is guys out there are great when they're describing 3D printers and how they can make really detailed items. But the thing that really messes up somebody who's looking to use it for some kind of mechanical purpose is oftentimes maybe it does really good detail, but it's just not very dimensionally accurate. And that's a real problem when you're trying to make something function mechanically. Because when we do prototypes, oftentimes our prototypes, they have to be pretty close. And I know that some of the commercially available FDM printers, they're getting down to 5 thousandths and uh, that particular range. Now, we also have resin printers, which I have bought. We bought a frozen resin printer, which is good with detail, but we really can't produce anything that's genuinely round. Now, we're able to do square things pretty accurately so long as the build isn't really big. But round things, we've really struggled and we've done all kinds of experimentation. The thing that we found that works the best is printing something round straight up and down and to have no support other than maybe kind of a platform and then the part directly. And we don't print things tilted on there because it seems like anytime we print something tilted, it ends up kind of being an oval instead of round. And we've fiddled with that all kinds of ways, can't figure it out. Now, that being said, a lot of the resin printer companies, well, at least some of them, I guess I shouldn't generalize and say a lot, but some of those resin printing companies are now using 4K screens. And if you're familiar with how a resin printer works, basically you have a screen and it will have a design that it will display in that screen, and only the areas that need to be printed will be clear. Everything else will be black on that screen. And then there's a vat that sits over of liquid. So what happens is only the area that is lit up, it will make that outline, it'll print that outline because that resin will solidify where the light shines through. And then there's a build plate that comes down. So it solidifies this resin on the build plate, and the print actually happens upside down. So it's a great idea. Precision wise, I don't know yet. We can't get the one that we have to work that well. Now, our particular one uses LED lights, and it has these kind of bulbous LED lights in there to be able to supposedly get more of a pattern of light that's going in through to be able to make the print. Now, whether that's true or not, I'm not sure, but I kind of believe that it does spread out that light a little more evenly. But we still just can't get the print quality. So we are going to try a 4K. Now, right now we are in the middle of the pandemic, or actually hopefully to the tail end of it, because it is June 2nd, 2020. And we're hoping that business will pick back up here again and we will be able to start back into manufacturing some new prototypes and new parts. We're kind of waiting a little bit because we want to see where things fall, financially, because our particular market, we sell a lot to the commercial world and we also sell a lot to the high-end hobby world. So we'll see. Um, Oftentimes, people in our particular niche, they will continue to buy regardless because you just can't get what we sell, which are precision headstocks, anywhere else for that price. In fact, we've had other people tell us that they got a quote on a set headstock that would fit their particular needs, but by the time they added everything up, it was like between $8,000 and $10,000, which I find to be really high, but that's what people have told us. And I do know that if you're going to get any kind of ID, OD, even a tool post grinder, you're looking at anywhere from $3,000 to $5,000 depending on the size of it. And in combination with our adjustable ER nuts, you can use ours to do the grinding to get it down into the millionths, where it would be very difficult to get those tool post grinders to be able to do that. Even though they're good and I like them, it would be very difficult to be able to get it to the level of precision that we can. Plus, the other thing I know this is a bit of a side rant, but plus the other thing to that is that we can take larger shank not cutters, but larger shank grinding points. And the advantage, especially if you get like a good carbide with a CBD or diamond on it, that it has a lot less tool deflection for grinding. If you have a 3/8 inch or maybe even a half inch, for doing an ID grind on something, you're going to have a whole heck of a lot less deflection than you're going to get, for some of these other precision ID grinders or even OD grinders that might only accept, like there's a lot of ID grinders like, an NSK and all that. You're only going to get about an eighth of an inch in there. I think some of them might take as much as a 3/16, but you're going to get deflection. And the longer the point is that goes in, the more deflection you're going to run into. And not only more deflection, you can also start to get hop. So that thing can start to bounce on the inside, and what you'll end up with is kind of a wavy surface in there if it starts to hop like that, and you can potentially even ruin your part. So I know it's a bit of a side rant, but there you go. Anyway, back to the 3D printers. Excuse me. For some reason, anytime I talk on video, I don't know what it is, but it really begins to make me yawn. I'm not sure why. So we will be getting a resin printer. Haven't decided which one we're going to get. We've kind of considered the Peopoly one, and we're a little bit considering, a little weary, the frozen one, because it just didn't have that great precision. But I know the new one is 4K and it's supposed to print pretty rapidly. Has a decent sized build volume since they make an XL version of it. So we may go that route too. It doesn't matter how you slice it. I think that we're probably going to be about $3,000 deep into a new resin printer. Now, I also want to be able to make an FDM printer, but I want to use ball screws. And we've also figured out a way that we can take a stepper motor and we can quadruple its accuracy so that those prints, and using a ball screw on the different axes, we should be able to really dial in the level of dimensional accuracy. So we shall see. I think we'll probably also have to invest in a little better extruder. The extruder that we have, I just have a Creality CR10, and that was our entry level. And for what it is, we did really well with it. It got everything we did out, and oh, sorry. I don't know what it's talking videos make me yawn. Again, sorry. I may have to just deal with it. But it did what we wanted it to do for the most part. We really couldn't make anything mechanical with it, but at least we were able to make representations of parts to get an idea of whether a physical feature on there made sense or not, or whether there was going to be some major interference on an assembly. So it did what we wanted. My only complaint about that one is that it just didn't last for long before things started to malfunction on it, and then I spent so much time just trying to track down and replace parts, and just to discover that we had a bad wire in the wire bundle, and that wire bundle was actually glued into place to the aviation plug. So we had to it was easier just to run a whole separate wire for the deal that registers the thermistor, that registers the temperature of the head. We had to run a separate wire. I never would have guessed. I replaced like the board in there. I replaced the thermostat. I replaced all these things. I would have never guessed it was just a wire, and it was a wire. Unfortunately, that killed a lot of my time when it came. Unfortunately, it killed a lot of time when it came to getting that thing back up and running. Um, and that one instance alone, I suppose that could happen to any printer, but that one instance alone kind of soured me on getting another Creality, even though it's got really good build volume, and by and large, I've been pleased with it. The other complaint that I kind of have, and this is about a lot of different printers, is that it's using basically a toothed rubber band to be able to move the z-axis back and forth. Not a big fan of that. I mean, I'm not real sure why they don't use screw mechanisms because of the repeatability that you should be able to get off from that. I mean, I understand that it's quite a bit cheaper to use that rubber band, and I know that a lot of those companies advertise that they're down to five, thousandths accuracy using that tooth rubber band kind of deal belt. But I find that very hard to believe, and I don't know how you could maintain any kind of consistency when it comes to the belt. I mean, the thing is constantly going to stretch, and and you have to look at that. You got to pay attention to the stretch on there because as it stretches, if it starts to get a little slack in there, everything is messed up because it's got a kind of a gap in there. When it goes to move the head, it'll take a second for it to move each time it needs to make a change. And when that happened, I'm like, oh, what's going on here? And it took me a little bit, and I figured, oh, it's just I got to tighten that up. So that's something you got to constantly watch. But you'll still never really get the accuracy that you might desire as an engineer or a prototype builder if you're looking to make anything that's genuinely usable mechanically, unless you've got something that can be really sloppy and is all right. So we will experiment. I've also thought about using servos instead of steppers. I'm not a huge stepper fan, but because we are able to quadruple or even better the steppers, we're thinking about using steppers. And you can also get steppers that are, most of them are 1.8 degree. In the market now, you can also get 0.9 degree, which is, 100% more accurate than the 1.8. Now, I have heard from some people who have tried those, and they've tried them on the X and the Y and the Z and the extruder itself. And then I've seen a couple people, they said they noticed a difference, a minute difference when they used that on the extruder, but for the actual axis, they didn't really notice any particular benefit to it, which which is a little unusual to me that they wouldn't notice any benefit to it. The only thing I can think of, it could be that just whatever they're using as far as an Acme screw or using that rubber belt to move the z-axis back and forth. Doesn't matter what you do mechanically, maybe it's just subpar. Now, the other side of that equation too is obviously the more accurate a ball screw you can get, and if you can get a ball screw that's got oversized balls in it, or you can get the two nuts on the ball screw, they're kind of opposed to each other and they push away, that you can take some of the backlash out of there. So those are all things that we plan on doing, and we'll probably go with some ground ball nuts as opposed to the extruded C7, or we're also kind of thinking about, well, you know what, maybe we should just go ahead and get the extruded ball screws to start with and see where that puts us, because I don't know, if we get the results we want out of a grade C7 instead of a C3 or a C1 ground ball screw, why pay all that more money? Because anytime you go down, to smaller and smaller numbers when it comes to error, the price goes up just geometrically. In fact, once you, for example, if you get something in the world of machining or grinding that is less than a thousandth, each time you go down 1/10,000th, it can double in price, just because it's a hard tolerance to hold. It's a hard tolerance to hold, and it's kind of funny too because I will get, guys periodically who want to buy a Shoreline and they want to get something or a Chinese blade that I'll be talking to them about or mill, and they want to be able to get down into the 10,000s. But the reality of it is it's possible, but it's not probable. You'd have to be an incredibly patient person. And if you're going to be doing this, with CNC, you may not be able to do it unless you got some genuinely good components on there, and your feeds and speeds are just like perfect. I mean, you can't cut off too much material at a time. You're gonna have to make a lot of thin cuts to be able to get what you want. Uh, it's a tough thing to get less than a thousandth on a small mill. It genuinely is, and but if you've got a material like wax or something like plastic, maybe you can really get down into it so long as you didn't get the thing too hot. And once it cools down, it settles to a different shape or dimension than when it was cutting. And the cutters, I tell you right now, the cutting plastic, especially high speed, you've got to be really moving right along to get those done because otherwise that stuff really gets gummy fast depending on what plastic. I've had better luck out of hard plastics because the chips eject a lot better than the soft stuff. The soft stuff tends to stay in there and cause problems. But if you got a good blower system, just blowing those chips out, um, you can get away with cutting almost any plastic. But the softer it is, usually the gummier it is, and more challenging it is. And I also like, by the way, I also like to use uh, a single flute cutter with those. So the single flute cutters seem to work best, and you can just zip right through. The more flutes you have, the more problems you're going to have with it, no matter how you slice it. So I would avoid going with a 4 flute or even a 3 flute. I would start with optimally a single flute or a 2 flute. But yeah, go for the single flute. That's the best. A lot of guys who sell single flute sell them for routers. Definitely, of course, don't use those diamond shaped ones that are made for cutting composite because they'll just gum all up. And that brings me also to composites. I have actually done really well just using carbide and high speed or cobalt and cutting composites. But keep in mind, if you're going to cut composites, one of the big challenges to cutting composites is that it's very abrasive. So it will wear on your cutter. And sometimes when it comes to the design of what I'm doing, I will make the fixture so that I can have the cutter at any depth to do whatever I need to do. So it maximizes the tool life. So if I'm coming in to make a side cut, I start kind of near the tip of the cutter, and then as it gets dull, just keep moving down until I've used the entire length of that cutter on that part. If I'm doing a profile operation, obviously, it's probably what a lot of you will be doing with carbon fiber is profiling and not really any pocketing. So I will use that. That way I can use the entire flute length and get a whole lot more out of that tool than just trying to, use that first little bit on the tip and cutting through it unless it's dull, either toss it or have to get it resharpened. Ugh, ugh. The funny thing is I just had some caffeine not that long ago too, and I'm still all yawny. So, there's some suggestions for you. Now, as far as what we use for drawing is we use the Fusion 360. And the nice thing about the Fusion 360 is now so many people use it that when we send the file out to maybe have something done, because I don't like to make the technical drawings, that it's just so tedious for me. So I'll just send out the drawing file and have somebody make the technical drawing in a PDF. That way I can send it to a manufacturer for them to build part. Because a lot of what we do is we will build the prototype and we don't do the actual manufacturing of those parts themselves because it's just not cost effective for us because for us to invest in a large machine to get to the level of accuracy that we need for our parts, we'd have a really big machine that would sit around unutilized for possibly, long stretches at a time. And the difficulty with that is actually twofold. Number one is I'm still making a monthly payment on a machine, whether it's running or not. So you want that thing running and producing money, all day long, since you have the machine. I don't have really time to take on outside work to bring in to put on that machine, or the manpower right now. The other thing with the machine is it's not just a machine. You've got to have, a temperature controlled space to put that thing in. And, you're going to want to run three phase to it and all that stuff. And I don't have three phase service where I'm at. And the price to run three phase here is another 10 grand. And, that stuff all adds up. And the, on top of whatever tooling you want to get in there. And of course, by the time you spec out a mill, with all the options that you want on there because of maybe what you think you might do in the future, because it's easier to get it now than it is to retrofit it in the future. And now the price is, geometrically gone way up, such as life. But it just didn't make sense for us to bring in, a super precision lathe and buy a precision grinder and get a large capacity mill and all that to, for production, because we'll just do those short runs and we're good. So we may as well use somebody else that has a bunch of money into really precise machines, and we're just another job among many jobs that are always running. So them making a monthly payment makes sense because it's always paying that monthly payment. For us, it just wouldn't be doing it. And I don't, like I said, I don't have time to go out and get other jobs because I run multiple businesses. I run multiple businesses, and the mechanical part of it with the headstocks and all that's actually my most fun business. I enjoy that the most. But it's not. Excuse me. It's not really the income level that I would just, the market's not really big enough at, the price point that I sell things at that I could, jump in with both feet and just go at it, because some of my other businesses actually pay pretty well. The, Shuralines and Tags, they're able to make a whole business out of those because their price point is as such that you've got a lot of buyers at that point. But mine is more of a higher end commercial quality. So there's just less buyers at that point. And then from there, it might jump up to, some people might go to the Tormach, or I've heard, I've not talked to anybody that's used the Novacon, but I mean, they look good. I've heard a lot of bad stories about them. I don't know. You'd have to look that up, make your own judgment call. But then again, even more recently on YouTube, there's a video about the Tormach. The guy had a pretty bad experience. And if you read through the comments, there's a lot of people have had bad experiences with it. Now, I get it when you're a business owner that sometimes people just can't operate a machine because it's just user error. But there's enough of them there that it would give me some concern over buying it. And there seems to be a repeated theme in some of these companies that the customer service, once you've actually bought the machine and they've got your money, you've got the machine, that the service might not be so good. And that's unfortunate. That's genuinely unfortunate because that particular level of machine costs, I mean, there's a real market. There's a lot of guys there that could really be great to use that to get their company, started up. So I don't know. I don't know if I would buy one of those or not. There's another one called, it used to be called International Hobby CNC. And I bought one of those, and I think all said, I think I bought it delivered and everything. I maybe paid $13,000 for it, and it was a full CNC. It was a DC motor servo system, and supposedly it was It had good ball screws on it, and he had some really good design features on it. It was a NTMB 30 taper on there. I didn't want the RA. I like RA in as much as the tooling is cheap. It's all over the place, but I'm just not a huge fan compared to having something that has a longer taper on it that can go inside of the bearings. But at any rate, I bought that, and man, was that one is just a disaster. The Sometimes when you have a machine, if it makes the same error in the same spot all the time, you can engineer around that. You can plan around that. But if the error is just random, it's like, what? How do you compensate for random error? And I worked back and forth and back and forth. And then we had a problem with the fourth axis on there. It just wouldn't work right. And eventually we replaced that. And the next that one did work right. But eventually I ended up sending that machine back, and they sent me a brand new one. And that was just such a hassle getting that thing boxed back up and out to the freight company. And we got the new one in, got all that set up. Same problem. Made no difference. Just terrible. Just terrible. Now, I know that they got bought out, and I don't know what the quality is of the mills that are now produced. I think they use a different brand of servo on there. The servos I believe they were using, you can get those at, what is it called? Something Technology, Automation Technologies, Inc. Uh, but they now are using they call them the stepper killers. What are those called? I can't think of it. They're an integrated servo system. I like the idea of them. However, the torque curves on that really aren't ideal when you compare it to a lot of AC servos out there. I mean, there's some real advantage. I do love the integration. I love that it's kind of got some automated portions of it. It's really kind of a neat deal. But I think dollar for dollar, there are other options in the AC servo world, like KMM. Is it KMM? I think it is. Out of Canada, that you can get more reasonably priced ones. And even our store, we're offering, well, right now, because this pandemic, things are a little bit weird. Probably won't be till fall, but during fall, winter, we will start offering our own AC servos. Yeah, and the ones that we will offer and how we have it set up for the small machines will just make it unbeatably accurate. Unbeatably accurate. So now, whether or not I would buy a, you know, $10,000 mill like a Novacon, or in fact, let's look up Novacon right now. See how much they are. I think they're out of Canada, if I remember correctly. Let's take a look. They go and called Taurus Pro. Well, it's not a very intuitive website here. I just want to buy it. I don't want the stand. I don't take replacement parts. I just want the machine itself. Oh, there it is. So the Taurus Pro with a stand and stepper motors is $12,500. Servo is $15,500. So that's $3,000 worth of servos. And kind of pricey. Let's add the PC on there. So yeah, we better get a fourth axis driver on there now. So you're looking at an optional automatic tool changer. You can get a power drawbar. Let's see. Yeah. It doesn't say if that's like an RA or what is on that. Let's take a look at the data sheet. Oh yeah, it uses like the Tormach tooling system style stuff. So I'm not a big fan of that. If you can get away with going to like a 30 taper, yeah, it's an R8. It's got a 6,000 RPM spindle, a horsepower and a half. Ball nut backlash is 5 to 10 thou. Cumulative backlash is going to be, well, a little over 1,000. Servos are 2,500 PPR. 500 inch per minute rapid's pretty good. But it seems like have they gone up in price? Let's take a look at their other one though, the Pulsar. It's $9,000. And the electrical cabinet is a mess. Why would they show it like that? You have to check that out. Go to their website and look at the electrical cabinet and the Pulsar. I have never seen, well, I shouldn't say never seen, I see it all the time. It's pretty common. It's got some really bad cable management. A little bit of a rat's nest in there. Let's take a look at that Taurus Pro though. I want to take pictures of the inside of that because that also could be a real rat's nest in there. I'm not seeing a picture inside the electrical cabinet. Alright, let's take a look at how much they want for the ATC. Man, it's not organized in a way that is that good. Well, let's sort here. ATC tooling. And they don't have that much of the tooling style tooling. Looks like they sell, they're a dealer for Bobcat. I don't even know how Bobcat stays in business. Because frankly, the cam that you can get for free with Fusion 360 kind of blows that whole thing out of the water. That I bought initially when I first started in this, I bought Bobcat software, and at one point it was actually became a Bobcat dealer, but we quickly dropped that line because Autodesk started selling stuff out there that's much better. I mean that was a very time-consuming and overly complex workflow on how to get things done. Let's see if we can find out how much the ATC portion of this thing is. Oh, here it is. I guess I missed it. 4,200 bucks. They show they don't really show an actual image of it. It's a rendering. And they must not update their website much because it says available for purchase by November 2015. So, I don't know. I wonder if they're actually doing it or not. Interesting. Well, let's compare that to, let's look up the International Hobbies one. We'll just type in IHCNC and see what we get. Yeah, it's now called Charter Oak. Let's see what theirs are. I mean, I know it's a retrofit. Yeah, it's a retrofit Chinese one. Looks like their Mills base price is $23.50. They got a quick change tool system that uses NT30. That's nice. Heavy duty stand. 3-axis Dro. That's nice. 2,200 bucks. You can get a Fagor on it, 40i, 3-axis. Let's see here, NT30 spindle. Travel, that's not bad, travel 26 inches on the X, 12 inches on the Y, 22 inches on the Z. Where are your prices for the CNC? Let's take a look here. The CNC version of it, next to price. They got a direct competitor comparison to the PCNC 1100, which has substantially smaller work capacities. Axis volume is 7,150 for the Charter Oak, 2,778 for that Tormach. I wonder what they're using for. Looks like a 3-axis is, oh, there's a price. 11,500 bucks. 4-axis, essentially $13,000. Before adding any upgrades to this thing. Let's see. See what it says about precision and accuracy. Oh, what happened? We just pushed the precision accuracy thing, didn't do anything. It says here it's got P3 grade ball screws. That's not bad. Why is it not giving me push accuracy? It's not giving me anything. Because what you really want, is to figure out what your repeatability is. Because if you make one part, you got to be able to make all the parts just as accurate. It says here it's servo driven. 3 horsepower spindle motor. That's like twice what I think the. No, it goes 3,800 RPM. It's not real fast. Maybe they have a option for a faster version. Man, the pictures on here are not that good. Oh, okay, yeah, they use the integrated servos I was talking about. I can't remember the name of them though. Their electrical cabinet is wired a lot more neatly than the Novacon for sure. Let's see. Seems like they offer another one too, though. Oh yeah, the Sail. I think that's how they're said. It looks like they now offer a lathe. No, it's just a manual lathe. Let's see here. X5 Pro. Well, that's kind of fancy looking. No price on it. Oh, there's a price. 10 grand. Work envelope's not very good on the Y-axis, 6.3. Not very good. That's the problem with those Sails. The working area is not real great. I haven't read any reviews on those. I'm kind of curious what the oh, it got a little lathe. 15,000 bucks. Got a Siemens control bar on it. Yes, Yaskawa servos. Impressive. Motor torque 2.4 Newton meters. That'll do. Double nut ball screws. Repeatability. Looks here around 10 micron. 0.01 millimeter. That's not bad. But 15,000 bucks. I think there's another company out there that you can buy their remanufactured ones at about $15,000, and they're 50 millionths. And let's look up the Sail. Oop. No, there it is. It looks like they make a lot of them now. take a look at the machines. Mini 5 Series maybe. I guess Siemens controllers on theirs. Where's their sweet looking ones? There you go, vertical machining centers. Holy smokes. $44,000. I mean, you can get into a Haas for that. Neonite cast though, that's nice. Five-axis capable. And it's got roller guides on it. Onboard probing. You can get available pallet changers on it. What kind of cooling you can get on it. They don't really give you any specs on it though. I mean, for that price, I think they want to have some specs on the website. Oh, BT40, BT50, so that's good. So you can get 12,000 RPM direct drive. Laser inspected ball bar test. Now here's some specs. It's at the bottom. Now here's travels. 650 millimeter cross travels. Like, wait, you know, the Y is 20 inches? Is that right? Looks like the X, it's got to be, oh, what is that? Bigger than 20 inches. That's got to be like 27 inches. Headstock's got like 20 inches. Distance from spindle surface or center to column, 550. Let's see, tool storage 24. We'll take a 15 pound tool. 1.8 kilowatt drive motors. Spindle motor is, wow, 11 kilowatt. 5,000 pounds. Looks like we got a bigger one too. Oh, spindle options. You can get HSK on it. I like that. Challenge with HSK, especially if you're a smaller guy, is it costs a lot of money to tool up in that. HSK AC, oh, that's not a cheap option. It's $13,400 and $15,000. But it's 20,000 and 24,000 RPM. So here and there, ballpark wise. It's like a 5-axis controls, an extra $30,000. 5 or 4 grand for a FANUC control. Chip conveyor. Man, you get coolant systems, another 5 grand. A chip conveyor is 3 grand. Man, even the rotary table is a little bit pricey. $10,000. A rotary servo table with a 5-axis, 17,000. Tool presetter 1000, wireless probing 4500. Man, if you really wanted to get a fully loaded one of these, and I kind of wonder what you're going to get for service on it. I mean, if you get like a Haas, they've got dealers all over the place. And I've never owned a, well, I take that back. We've had several Haases that we bought and sold, but we never used them. We bought them to sell. And I've been told by a lot of other guys that their customer service is actually quite good. I think in this price range, by the time you added all that stuff up, I'd probably go with the Mazak. I'd probably buy a Mazak. Because, I mean, this, to get everything you want on there, you've probably got a $100,000 machine. And I wouldn't do that. I wouldn't do that with that brand. And I imagine the resale on it. You know, I kind of question that too. What, you know, what its actual worth is after that. Yeah, so what's the, let's see, we took a look at, well, Tormach, most people know about Tormach. Oh, excuse me. That's a Denna one. That's small. There's one out of Canada, and I can't think of its name. It's not the Novacon. But they sell CNC parts, and then they were going to do their own that uses the same base mill as that Charter Oak or International Hobby. And I mean, they had some really good ideas on it, but last I knew, the project never got traction. Never saw it marketed. You know, something else I've often wondered is why can't we just take, you know, a good servo CNC machine and, you know, use that as a 3D printer, because now you're inherently got a lot more accuracy. Something I have to look into. Maybe we can take the TAG and turn that into a 3D printer. Let's look that up. Convert CNC mill to 3D printer. There's a video on here back in 2014. Too bad there's not anything newer than that. There's one in 2012. This is a thing on Instructables. Here's the January 31st, 2020. I wonder what a Supermax is. This guy says he's got a Supermax. Let's look that up. Oh man, that's an old beast of a mill. See if there what people post about converting. It seems like Mach had something on there that you could use to convert it to a 3D printer. Not have enough resolution. This guy's been doing it for quite a while on Shoreline A to Z CNC. A to Z CNC. Oh, they went out of business. Wonder. It was too bad too. They had kind of a neat thing going. Let's take a look. Yeah, still out of business. Oh man, I'm looking at the print job. It looks crappy. Oh, that's terrible looking. Ugh. Hmm. Yeah, that doesn't look good at all. Maybe we just type in Mach 3 3D printer. Here's the thing here on how to use it for that. There's an add-on. I don't know how up to date this thing is. There's a March 17, 2020. Hmm. Interesting. Alright, and I'm going to save this. I think I got a 3D printer in here somewhere. Maybe I don't. Hmm. That's really weird. Oh, 3D printing. Duh. Hmm. Oh. Okay, they stopped updating this website. It's the name of the website is called CNC2Printer3D.WordPress. Now let's see if we can find anything else. Let's take a look at the Instructable one. Haas has a video in here, and I bought one of his the kits, conversion kit, and built one of those ones. How well it turned out. Hmm. Yeah, that's kind of interesting. I wonder when this was, an article was made. Hmm. Yeah, we're definitely going to do that. Let's see what this GenX temperature lab controller thingy is. Oh, okay. I wouldn't really buy it. Oh, it's back to that other website we went to. Oh, it's a whole extruder controller. In theory, this thing should work really well. I don't like the idea of 12 volt to do the hot plate. I could convert that to a 120 volt like I did to my Creality. Oh, he's got a whole parts kit, doesn't he? Oh no, I guess it's not for sale. It's just somebody showing what they made. Oh, okay. He needs to, I wonder if he just gave up on his website or what. Now let's go to my website, Glock CNC, and see what's happening there. Yeah, it's really running slowly. All right, let's see what kind of numbers we got. Come on now. Wow, 206. Actually, the numbers are pretty good. Suppose they're not making more sales. Let's take a look at the store, I guess. We'll go to abandoned carts. So we've got a couple potential sales here.